Hi, good morning, and welcome to the ZP Developer Zone. So this morning I am at Medica. So Medica is a big medical devices and diagnostics conference in Germany in the next few hours. Something like a sort of 150,000 people will be coming on site. So it's a bit weird because the background behind me, as you can see, is Medica. I'm sort of not in a private space, I'm in a public space, but we're going to go ahead anyway. So welcome to the ZP Developer Zone. We do this every Thursday at 8 a.m. London time. And today it's unusual because we're not doing it from the UK, we're doing it from Germany, for Deutschland. So let me jump into this and try to be quick and efficient with your time. So any questions of Zimmer and Peacock, when it comes to technical, there's two free courses on the ZP Academy called one for electrochemical methods for biosensor developers, and I think there's one introduction to electrochemistry. Anyway, that said, there's a couple of free courses. We do these webinars every week. We try to support the biosensor community through these webinars where we answer questions. We do have collaborations. Some of our interactions with the community, I would describe them more as collaborations because they're quite ongoing. We do post jobs. We were going to the Imperial Biomedical Recruitment Fair this week, and we also have our ZP Developer Zone. So if I go a little bit quicker now, and then workshops. And on workshop front, I want to say there's a workshop next week in India. There's two-day workshops. ZP will be at both of them. So I have a colleague who's going to be on site, and I will be joining, and several colleagues will also be joining online. So we do have workshops. There's two in India next week. There's one in Norway at the end of the month. There's one in Coventry in the UK also in December, and there's another one in Grenoble also in December. We also do, as I say, these workshops. Now, there's a few questions that have come in this week, and then one of the questions was about constructing a credit card microfluidic. If you can hear, as I say, background and stuff like that, unfortunately today that's the way it is because, like I say, I'm at this trade show, and I'm doing it essentially live from the trade show. So the three questions we've got are constructing a credit card microfluidics, testing sanitizers in water, and measuring lead. So let me just go into it. So at Zimmer Peacock, microfluidics are really intrinsic to overall IVD, in vitro diagnostics. So if you have an in vitro diagnostic, you have a sample of blood, some sort of bodily fluid, and you're trying to bring it to the sensor. So microfluidics are really important. At ZP, we know that you can have all sorts of microfluidic designs and channels. This particular inquirer, I think, is interested in sort of having multiple sensors on essentially one device. And really that's I want to say that's really no problem. So what I will do is, whoops-a-daisy, is go forward and say, if you want to make a device like this and have one sensor here, maybe sodium, maybe a lactate, maybe oxygen, maybe potassium, maybe chloride, maybe hematocrit, really sort of no issue. I've just described really a section of what we call the comprehensive metabolic panel. The comprehensive metabolic panel is generally about 14 analytes that get routinely tested in hospitals. People want to now test this much more in a sort of point of care setting. Anyway, so if you can also just make microfluidics on a single sensor like this. This is much more like a sort of glucose sensor. So if you want to make microfluidics like this, we do have a set of materials for doing this. So you can make, for example, a glucose strip or a sweat patch. I've given a sort of another image of a essentially sweat patch here. So if you're interested in doing these kind of things, you can use the materials that we give or sell on the website to do that. I'm just going to make a couple of videos. Whoops-a-daisy. Make a couple of videos play at the moment. And just to sort of say that many of these microfluidics that we show on the website are actually constructed all from these materials. So the materials do have a lot of applications. You can either make microfluidics on top of single sensors, like take a hypervalue electrode and make a flow channel on top of that, or take a credit card and mount several sensors onto that credit card and do multiple analytes at a time. So as I say, at least these 3 videos where we show the credit card design and the single channel capillary device, these are all made from that kit. So there's a lot of versatility in the kit. There's a link here to the kit. Now I'm going to dive into the kit because the kit comes with 2 materials. It comes with this opaque material, and it also comes with this transparent material. Now the inquirer, I think a member of their team has already figured this out, but I just want to say that the opaque material, this white material, has what we call a bottom cover, a middle sheet, and a top cover. So it's a double-sided adhesive or pressure adhesive. So it's double-sided. So the person who bought this kit and was inquiring about this is, they've already realized this, but actually you can peel off the top sheet and the bottom sheet, and you can essentially stick it all together that way. I have a bit of a video on this. We do have something called the sweat patch, and the sweat patch kind of illustrates this quite nicely. So the sweat patch is something that we've pre-designed, essentially pre-cut, and it's made from the same materials. And when you watch this video, you can see the person come in, they're taking this white material, and before you know it, they're starting to sort of peel off materials. And every time they peel it off, then what's happening is once you peel off the top cover, you're actually left with this kind of quite an adhesive material, and then you can start sticking things to it. So the inquirer is right that actually you can, the white material has a top and a bottom cover, and you can peel them off and you can start essentially sticking things on top of them. The transparent material, as far as I remember, has no adhesive on it. So you often call that the kind of top sheet, that you use it to cover over the top of all your microfluidics and sort of put a sealing, let's say, to the top of your microfluidic materials. So if you're kind of interested a little bit in how to handle our materials, how to kind of peel them away, take a look for a video called a sweat patch from Zimmer and Peacock, and that does sort of start to illustrate that this opaque white material, yes, it is double-sided, and you can stick it together by peeling off the top cover and the bottom cover, and you can start stacking them on top of each other to make different depths of microfluidic channels. I will go on, I'll just click on a bit more now. So if I was describing how to construct a capillary fill sensor, this is one of our hypervalue electrodes. You can make these kind of features on top of it. Now these kind of features, I should say, that's a capillary fill. It will actually just suck in blood or suck in any sort of sample and bring the sample straight to the sensor. And the way we construct it is we just I should say stack materials on top of each other. So we would have knife cut the transparent material. We would have peeled off the bottom layer and essentially aligned it and stuck it on. Doing this kind of alignment when you haven't built engineering jigs, it's quite hard. It takes a lot of skill. Obviously at Zimmer and Peacock we have a strong electromechanical team, so putting together these jigs is really no issue. And then we can bring in the transparent material, and the transparent material will stick on top of that, and you end up with a chamber. Now that means you can construct devices like this. So you're not just pipetting the sample onto the sensors or electrodes, you're actually able to then capillary fill the sample. You might notice there's something called an air fill, an air hole. So I'm reading the email from the inquirer, and they understand that you need this air hole, because otherwise these kind of capillaries won't fill, because the air has nowhere to escape. I just want to say good morning to Aftab. Lovely to see you this morning, Aftab. So you can construct capillary channels and chambers using the kit, and the kit link is here. And you can then if you have things like knife cutters and the skill in stacking materials, then you can make these kind of devices, no props. If you're trying to make this kind of credit cards device, it's not something that we have on the website, but it is something I can add on the website. Is, you know, we essentially have these medical materials that are actually in the shape of credit cards, and I'll talk about how to make a sort of multi-channel cartridge here. I'll play this video here. I have to mute it. But this video that I'm just playing here is, you know, saying, well, look, you take this credit card, and we've actually cut away pieces of the credit card to make it into a sort of here you can see where my finger is. There's a hole there that's just perfect for the placement of one of our biosensors. So if you're wondering how we make these kind of multi-channel biosensors, well, we're taking these materials and we're cutting them, and then we're placing the sensors essentially into those slots. If people want these materials, then I can add them to the web store. I haven't at the moment, but that's something I'm just trying to make a mental note to do that. I mean, when we do this, we're cutting this kind of material on quite an industrial scale. So you can see here that this cutter that we have is, you know, at least 2 meters in length. So it's quite a device, but people can get much smaller scale versions of this, but this is how we're cutting it. So what I will do now is progress a little bit. So what I want to say is, if you want to make that credit card type device, you actually have to cut this polymer, put those sensors in there. Then you can stack on top the opaque material to build up the walls of your channel, and then put the clear cover on top to make the top cover. Just something that's coming from Zimmer & Peacock is these this will be a multi-channel reader, which can probably read 6 channels at a time. These are a couple of concept drawings, but we're designing these and I'm going to make them available. So essentially you can build a sort of credit card sized medical diagnostic, and you'll be able to slot it into this multi-channel and read something like 6 channels, up to 6 channels at a time. So that'll be a real game changer, because you know, the R&D community now will be able to get hold of a set of electronics that can take a credit card that will really allow them to kind of accelerate their medical diagnostic development. So just watch out for that pretty shortly. All right, so I will go forward a little bit more. So we've also had a question. This is quite important. There's a lot of water sterilization and maybe sanitization, I'm not sure if that's the right word, that goes on. One of the most commonly used materials is something called sodium dichloroisocyanurate, and I'm just going to sort of discuss that. So this is the material itself. NaDCC reacts with water and releases, for example, 2 molecules of hypochlorous acid, and this hypochlorous acid is really it's a form of, I think they sometimes refer to it as free chlorine, but it's basically a bleach. And this bleach oxidizes organic materials, bacteria and viruses, and ends up killing them. So we can actually detect this material using our how do I say, what, SenseIt-All platform. SenseIt-All platform has these sensors, the electronics, the app, the Julie clouds. So sensor goes into the meter, sample goes on meter, app runs the meter, app sends the data to Julie, and then Julie can give out a concentration. And in the case of this, I'll give out the concentration depending on, mostly people want sort of ppm, ppb type results. So that's how I would do a discrete measurement. So a discrete measurement, I would be something like this. Somebody had a volume of water. They wanted to, say sanitize it. They would take a couple of these tablets. They would drop them in there, and then they could sort of essentially leave it to do its sterilization. And then they could check that and see that actually the free chloride concentration was, or for free chlorine concentration was actually high enough. If it was too low, it tells you that you had actually had quite a lot of contamination in there, that all the chlorine is consumed, and so you have no certainty that that water is fully sterilized. And so this is a good way of actually testing, not only did I add chlorine, and if after, let's say, 20 minutes there's no chlorine left, it tells you that actually you've probably still got material in there that needs sterilizing, and you might need extra tablets. So this is a kind of what I call a useful spot test to make sure things were working okay. There's also these continuous systems. By the way, I just want to say this, when I'm showing these products, these are not products. This is just one of the leading, not products from Zimmer. When I say these products, I mean, I'm showing a couple of images of sterilization systems. Let me just hover my mouse over that. That is not a ZP product. This is one of the leading products on the market. But if you have this, you can have these products, this desterilization, or the sterilization rather, I should say, products also in the flow stream. So you have water coming in, goes through this container, and then you have water coming out, and the water coming out is essentially meant to be sterilized. But you might want to know how much free chlorine or hypochlorous acid is actually in there. So we would have to take one of our sensors. It's the same sensor as before, but it's now been sort of potted to make it more robust. That's it in its packaging, and this is the electronics. So what we can do is we can put those sensors will communicate with a base station via the electronics, and then the data will go to Julie. So we can also do continuous measurement. Earlier on I said a discrete measurement. Those are simpler. Once you get into the world of continuous, things do become essentially more difficult, but we can also make a continuous measurement device as well. And I think I'm just going to go up one. Yeah, detecting lead in solutions. It's really the same story as earlier on. Lead, I'll get to the data in a minute. We have the Sense-It-All platform. What makes a Sense-It-All platform analyte specific is the method of excitation and the data extraction. So we keep having this consistent story of a sensor that fits with a meter, that works with an app, that sends the data to Julie, the sample goes on the sensor. But for lead, it is a different method of excitation, and it is a different method of signal extraction. And that's the power of this platform that we've built, that everything stays consistent. Sensor can stay consistent, electronics can stay consistent, Julie stays consistent. It's just the app, when it's doing the excitation and of the app is telling the meter what to do. When the meter does that excitation, it's a different protocol depending on what we're trying to analyze. And then the data goes to the Julie, and it's a different protocol for what we actually want to extract. And so we send the data to the cloud, and the cloud gets the cloud extracts information. So that information is this, because Julie really gets the data in this form. So we basically get a raw signal versus here I have concentration, so we have 1 ppb, 2 parts per billion, 10 parts per billion, up to 200 parts per billion. Really interesting, actually, because what we're talking about here is 2 orders of magnitude. So it shows you really what the sort of linear scale that we can achieve in the detection of lead. So if the lead's at 1 ppb, then we can detect it, and if the lead is at 200 ppb, you've got a serious problem, but we can actually still quantify it. And so the whole system, the app tells the meter what to do. The meter gives the raw data back, which will look like this response versus excitation curve that I'm showing you. And then Julie can turn that signal, essentially, it could be a simple calibration like this, into concentration. And you get, and from that concentration, recap. So first of all, thank you for your patience today. If there's been any background noise, I apologize. As you can see, there's thousands of, there's a large space behind me. I'm at this show called Medica. In a few, less than an hour, there'll be 150,000 people start coming through here. So we're trying to do this live just before the show starts. So thank you for the question of constructing a credit card microfluidic. We do those materials. The white material has has cover sheets both sides of it. So it's what we call a double-sided sort of adhesive material. And then the clear material has actually got no adhesive on it, and you often use that to form the sort of top cover of the microfluidic. NaDCC is a very common way of sanitizing water. Those products themselves are not Zimmer Pigott, but we are able to quantify the free chlorine or the hypochlorous acid that's actually in solution. And then this week, the engineers have been validating that the Sense-It-All platform. Thank you so much for AFTAB for giving me that feedback. I appreciate it. So this week, AFTAB is online with someone. He really knows our scientists and our engineers. They're really good. So they went in and did some verification that we could detect leads in the concentration 1 pp up to 200 ppb, and we can do it all on the Sense-It-All platform. What I want to say about the Sense-It-All platform, just finally, is Sense-It-All platform exists so that entrepreneurs around the world can achieve what we call an MVP, a minimum viable product, very quickly. People like AFTAB, they understand this, that we have an API strategy, which means that people can call up our server, they can authenticate themselves, and they can pull the data across to their server, and they can give their customers a unique experience. So, you know, different regions of the world have different problems, and they have different languages, and so we're essentially acting like Apple in terms of a platform upon which other people can develop and be entrepreneurial upon. I want to say a special thank you to the questioners in question 1. Thank you. I realized by the time I did this webinar, you'd already sorted out your problems, but you can live cut that material. That's one of your questions. Special thanks to Smart Life and to AFTAB for his support over the years, and I look forward to speaking with at the Indian workshops next week. All right, I better go to this conference, but thank you so much and take care. All right, cheers, guys. Take care.